question we had from yesterday, which was like, how do we get static images into our apps? So let's start up. We have to find octocats.
Really quickly, how do you deploy the like we would do with npm deploy?
Yeah. You should be able to do yarn build.
Does it still build a search?
It builds, and then you just have to run surge manually. So yarn build will build us a production build, and then we should just be able to do. We should just be able to do surge. If we run surge, oh, I don't have surge installed. So we might have to install surge globally with yarn global add surge. So that will install surge. We can use it anywhere. And then, when we're done, we should be able to run surge.
If I get a new hard drive and do time machine, will all this still be installed?
I'll just install it wherever. Ready green surge. So just running surge manually should.
You do not have permission to publish to 10 airport.
I pressed search and it said running as, and then my email, and then it said project, and it had /users, and then my name.
Yep.
And all
Blah 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 blah.
But
octocats.
but like nothing.
Oh.
Nothing below that. No like link to anything.
Let's see. Surge build. Let's see if we can do this. So.
Do you have to rename the domain?
Yeah.
No, I mean you can rename the domain. There we go.
So search build.
Yeah. So here's so it'll be yarn add in your directory. Yarn global add surge one time. Then you can do yarn build.
Did this just come up with random names?
Yes. And then if you do surge build, you can specify the name on the command line, or you can type in your own name. It just has to be unique. So after that, if you do surge build, it will spit you out a right, arrogant bum.
I'm not able to post to any of this stuff. It's still
Just come with
warning you do not have permission.
just come up with a unique name. So put your name dash the name of the thing.
Okay.
Octocats, yeah.
I think I messed something up. It's still
It's
Okay.
still working.
with my new successful names. It's not.
Okay, cool. We can take a look at that in a bit.
Take a look at it later. Sorry about that.
That's okay.
As you were saying.
Let me get set here for a second because I want to show you. I think.
That one worked. Okay. Sweet.
Let me just rebuild my cats to the level that you all were at. Cats equals. Cat is. So we're going to talk about two things today. We're going to talk about how do we get static assets into our app, and then we're going to talk about state. Let me fix my code. So this is my data, right? That's there. And this is const octocats. That's to there. This returns to there. So what does that look like? Don't like the closing two parentheses here. So that's too many parentheses. Okay, cool. So this is probably kind of what your octocat would look like if you had gotten to the point where you extracted the cat data into an object. So here I have some data that is my cat number, its name, its image, its link, and then authors. and I built mine with authors being an array that has a nested object inside. So you may have just had like author image here. Maybe you had this.
Why'd you use instead of the equal sign, you use the colon?
Because I'm making an object, not variables.
Okay.
So maybe you had done this, and then this would just be author image. And so you may have ended up something that looks like this. So let me grab another cat. So I've got all the cats here. A file. Something cool like that. So let's put a second cat here. Right? So if we had multiple cats in our file, this. Alright, so here's cats 144 and cat 143. So we're saying our data is an array of an object followed by another object. And then we're saying our cats are as if you take that data and turn it into another array, where you go one cat at a time and turning that into an octocat component, passing this cat number as number, passing this cat's name as name, passing this cat's image as cat image, passing this cat's author image as the avatar image, and passing this cat's link to link.
I thought that was supposed to go into the octocat file.
When you pass the arguments, they come from the parent. And then in the octocat file, you use them. This.props.cat image, this.props.number. In here, we're setting what the properties are. And here we're using what the properties are. So in the parent objects, the parent is the gallery is the parent of the octocat, right? The octocats are contained within the gallery. You're going to say, please give me an octocat. By the way, your number is 144, your name is umbrella cat, your image is this URL, your avatar is this URL, and your link is this URL. When the octocat wakes up, it pulls those bits of information out of this.props. So the parent passes properties to the children, right? Just like your eye color is your eye color because of your parents, right? You get those things from your parent. The parent creates the octocat and gives it its attributes, its properties. So what if we wanted, in our app here, this logo to come from us, right? We're not going to pull this logo in the footer. Right. We don't want this image to come from logo.png up on GitHub. We would like to have our own logo. So I threw this image B into my folder. I've just got this b.jpg. I would like to be able to import that. I'd like to be able to use that image in my app. So to do that, we have to talk about assets. So this will be in the handbook once I commit it. So in React, we can also use import to load assets. So we've seen already, if we look in our footer, like we import React, right? In our gallery, we import our octocat. We've been using import to pull JavaScript from one file into another, saying, this file would like to use octocat. Right? If I'm going to use octocat here, I have to import it up here. Right? I can't use this octocat unless I tell the system where to get that octocat from. Well, the secret is that import can load more than just JavaScript files. We can use import to load assets as well. So React apps use a tool called Webpack. Webpack is a tool for packaging assets. So when you do that build stage of your app, or when you get those errors that were popping out, those are coming from Webpack. Webpack is taking your JavaScript, all those different .js files, and packing them into one JavaScript file that can be handed off to the browser. Right? So why would we do something like that? Well, this is not regular JavaScript. Right? This is JSX. This is something React does. Right? You can't just go to a regular JavaScript file and type this, because JavaScript will be like, what? why is there a less than and an octocat here? Like, I don't know what that is. You've got HTML in the middle of your JavaScript. No. So Webpack essentially does two things. It can transform your JavaScript, and it can pack all the JavaScript into one thing. Right? So our various app.js, footer, gallery, header, index will all become one file when we deploy it to Surge, or we deploy it to Heroku, or to wherever our company's data center is. It'll take all that JavaScript and pack it into one file, and it will turn any kind of special code in our app into the thing that it needs to be. The other thing that Webpack can do, through using some other tools, is allow you to use new features of JavaScript that the browser doesn't yet understand. So maybe your browser that you're deploying to doesn't understand the arrow syntax, because the arrow syntax has only come around in the last little while. You're going to deploy this to IE6, that's not going to work. But you can use Webpack to say, hey, if this is an IE6 browser and you got an arrow function, this is how to turn an arrow function into an old style function, and it will just do it for you silently in the background as your code is all being packed together. Right? So Webpack is a tool for processing and packaging assets. It can handle JavaScript, JSON, images, fonts, CSS, and pretty much anything else that you invent, as long as you have what's called a loader for that. So we configure Webpack with various loaders to import various data types. So by default, it knows how to load JavaScript. But in Create React app, they add support for loading JSON, images, fonts, CSS, and other things.
So instead of import, we use loaders?
Nope. Well, the loader is the implementation. We're still going to use import. So if Webpack pulls from our source and helps generate JavaScript, we can import an image. So instead of here in the footer, let's import our own logo from b.jpg. Import our own logo from b.jpg. So this, if we do that now, and we happen to console.log our own logo, let's see what that is. Right, so b.jpg is an image. If you actually open this up, it would just be like, you get weird characters if you like. If you happen to look at what it looks like, right, on the, right, that's what a JPEG file looks like. If you like put it on the terminal, it's all kinds of weird codes, right? It's binary data. Let's see what it looks like in our app. So if we go to our console, we should see, what's it look like? We reloaded it. Just defined but never used. Oh, door. I have to put it inside the render function. So now that I do that, you can see right here, it is a URL. This is our own logo. What importing an image does is it gives us a path or a URL to where that image will live. Right, so it's saying that that image can be found at static media b.thisweirdnumber.jpg. So why do we have this weird number here? This weird number is the unique identifier of this B image. Right? 49EA identifies the contents of that B image. So here's something you probably don't know about your browser, is that your browser aggressively caches things. Right? So if you see this GitHub logo and you reload the page, it's not going to ask for the GitHub logo again. It's going to cache that information and say, I got the GitHub logo last week, I don't need to ask for it again. Right? And we can set durations on how long things get cached for. How long should we cache the logo? And let's cache it for a week. It doesn't change that often. But what happens when it does change? How long will it be until all your users get the new logo?
A week.
Up to a week. Some will get it right away, some will get it after a week. So what a lot of these packing tools will do is they'll put a unique number in here that represents the contents of B. So if I change the contents of b.jpg, that number will change. If that number changes, your browser's like, well, that's not the same image I saw yesterday. Yesterday it was B49E8, blah, blah, blah. Today it's b.9732. I need to get that. And I'll cache that for a week. We call this slugging. This part here we call the slug, right? It's a number we put into something to uniquely identify it, so that when we replace its contents, that number will change and we'll get a new copy of the content.
What part of our of React did that for us?
That is the image loader. That's part of Webpack.
Okay.
So somewhere in our Webpack configuration, it said, hey, I know how to load images. When you load an image, what I will do is I'll give you back a URL to the slugged name of that file. I'm betting anybody see that same number? Right, 49E8A5BC. So MD5 is a checksum. It's called the Message Digest 5. Anybody know that credit cards have checksums on them? Right, there's a digit in your there's a digit in your credit card.
Is that like the same thing as an MD5 hash?
It is exactly the same thing as an MD5 hash. An MD5 hash is an MD5 sum.
Okay.
So credit cards have a check digit in them. Right, that's why like you can type a credit card number in online. It's like, no, this is not right away. So what it's doing is it's adding up all those other digits and doing a modulus maybe against something. And if that doesn't end up being the same digit in your credit card, you may have transposed numbers or type a 9 with a 7. Right? It's a very simple checksum. Barcodes have checksums. Lots of things have checksum digits in them. Your hard drive and your memory have checksums. Right? If you have error correcting memory, what it does is it stores the data and another checksum and like an XOR of that data, so it can recover it. They can look at the checksum to know if it needs to be recovered. So checksums happen in a lot of places. What you need to know about them is it's a unique number that represents the content of that file in a much smaller form. So if I go into b.jpg and I change one character, one byte, one pixel of that image, that number will be radically different. So I just open it up inside of a tool and like change one pixel from white to red, I'm gonna get a totally different number, which will give me a totally different path, different slug. So if this is just a URL, right, what I should be able to do is instead of saying, hey, the image source here, let's just say our own logo. Because what's inside of our own logo is a reference to that file. And now I get my little B JPEG in here. Right? So if you want to reference a specific image, the way we do it in React apps is we import that image from its path and we pass that as the source of the image, right? Because if we try to do this, /b.jpg, right? Right, we're gonna get nothing, right? And we're gonna try source, we're gonna try all these things, and none of them are gonna work. And what you would do is you'll find a solution that will work locally, and then you'll deploy it to Surge, and it won't work anymore, right? Because you notice there's no b.anything, b.498 in here. When we go to deploy it in our build directory, we will end up with a b.file in here, I think. I think if we yarn build, I think we'll end up with a b.49 something something.
And that'll be somewhere in the build directory?
I think so. If this is set up correctly, it will.
So once you like link it to the BJPEG, it really is, it's there forever, even if like your computer explodes or something, it's still like a thing you can just link just from your local file right away.
Yes, absolutely. See, it put a copy of B into our build directory, but it called it b.49ea something, right? If I open this up, it's the same B file. It's just been in our build, this has been called b.49. That way, when we have it on the internet and someone downloads and caches this, if I replace this B with a cursive B, it's still called b.jpg, they'll immediately get the new copy. So, cool, we can import JPEG files. What if we didn't want in our gallery to have to define all this data? Right? We didn't want to have to like type in all of these octocats. So I made yesterday an API for the octocats. So this goes to the Octocat page, pulls down the HTML, parses it all, pulls out all of the data, and presents it to you as a big JSON file. So sdg-octodex.herokuapp.com will give you the entire set of Octocats. So what if we took all of this and copied it and made a file called cats.json, which I've done here. So I made a file called cats.json, which just inside of it has JSON representing all of the Octocats. Right? I would like to use this data in my app rather than me defining in gallery this data. Right? I would love to get the cats from that JSON file. Well, luckily for us, we have a JSON loader. We can import that data from cats.json. And then instead of me hard coding it, that data will come from the JSON file. If I console.log data and I map that data, oops. Okay, cool. Except if we look in cats.json, the data is in an object, then there's a status, and there's a data. So this is really data.data, which is going to be confusing to you. Let's do this. Let me go to cats.json and just make it be, let's just make it be what it is, which is this. Reformatting. There we go. Alright, let's just make it be the same thing. So I just, in the API, you'll notice that I kind of hide the actual cat data is inside of another attribute called data, because I wanted to know if it was cached or not. These are really like my cats array. So that's what I put in the JSON file. So my JSON file is just an array, just like this used to be, right? Data is an array, right, of an object, number 144. Now my cats JSON is the same thing.
So you just pulled the JSON file.
Yeah, I just copied the JSON off of my API.
So now you have two of everything.
I have, right, if I get rid of this, and I import the data from cats.json, I now have every cat.
What is JSON? Okay.
It's a way of representing JavaScript objects in text.
Where'd you get that JSON file?
I got that from going to my API that I built, and I copied all of this.
Wow.
Right,
So you did all that yourself.
I wrote the program that generates this.
Nice.
So I wrote a program that goes to GitHub's, it goes to here, Octodex,
You just pulled all the information from
Yep.
all the objects.
and I go through source, Octodex.
That's called web scraping.
And I scraped all the information off this page. So I wrote a program that goes through and gets all these divs and finds the link here, and it finds this image here, and it gets the name from here, and it gets the authors from here.
You should
So
submit that
forth
to
and so on.
GitHub.
Yeah. Here's your own
Somebody will be
API.
happy about that.
Yeah. Well, what's also nice is it caches it, so it only pulls from GitHub when it changes. So I can load
So
this
it
all day
will-
long, and it will not be hitting GitHub's site. It keeps a copy, and then it checks to see if GitHub's changed, and if it's changed, it pulls down a new version.
So if they posted a new Octocat, will your API automatically update? That's neat.
Yeah, if they post Octocat 145, my API will notice that page is no longer the same and pull down the whole page.
You get that info.
Yeah. So it works with something called an e-tag.
How long did that take you to build?
We were here yesterday, what,
Yeah.
15 minutes?
Yeah.
Jesus.
Or so?
15 minutes you pulled it build
Yeah.
the API?
While I was asking questions.
While he was asking questions. So there's something called an e-tag here. What does that kind of look like?
Like, I think we just
Like the
Like slugging
MP5
this off.
checksum or whatever.
So guess what this is? It's a checksum of the page. Right?
Wow.
Oh.
Right?
So it cached the whole thing.
Yeah. So if you ask for this page, right, using a little HTTP tool, there's the checksum of the page, right? But if I ask for, there's another way we can ask this. I can ask just for just give me back the headers. Don't give me back the entire page. Just give me the headers and look what's inside of that. The e-tag. So rather than ask for the whole page, I say, hey GitHub, pretend like I'm about to give you this whole page, but just tell me the header part, which GitHub can do really, really fast. And it requires like very little resources on their part. It doesn't have to like go and query the database and all that. It just says, hey, I've given this page before, here's a checksum. So I ask for the checksum of the page, and if that's the same as the checksum I've stored,
Then it doesn't need to hit GitHub.
it doesn't need to get hit, I just give back the last copy of the JSON I had from before.
What did you use to scrape that data?
I wrote a small Ruby program to do that, because that's my kind of go-to tool for small apps.
I've seen things like that done a lot in Python.
Mm-hmm. Same kind of deal.
A lot of data science stuff.
Mm-hmm. So how much easier is this? Right, I'm just going to load my data, and maybe I would call this cats. Maybe I'll call this cats JSON. Right, load my cats JSON from cats.json. So now I have an object. Right, literally it's like this is freeze drawing the data. This is like thawing the data out, right, from a file into an object. So now cats.json is all of this data, and then I can just map it into octocats, right? Such that, right, here's umbrella occat. If I come into this file and I delete this one, and I reload the page, right, umbrella occat's gone.
Your avatar.
What's that?
Your avatar.
Because I changed this to be, it's an array, so now it's authors of 0.image.
I see.
Yeah. And they're the avatar.
Little square or triangle.
Little triangle. I didn't bother with that. Actually, we stole this from your Octodex, so you didn't have
Is
the
that a
triangle.
CSS thing?
Mm-hmm. Sweet. Cool.
Can you show us how to do the triangle?
Yes, but not in this lecture today.
Okay.
Because we want to get through state, and state tends to blow people's minds. So we need enough time to talk about states. It's cool. So now we have how to load some images and use them. We've seen how to load JSON and use it. You may want to practice that in your rectified octocats. If you got to the point where you're mapping, take your array, stick it in a JSON file, load it from there. Let's talk about state. I'm curious if let's talk about state. Let's talk about state. That's not the theme I wanted, but I'm going to go with it. Right, so we know that React is based on components. We talked about this yesterday. And each component has properties, like our octocat has a name, right, and an image, and an author. Properties are read-only values, and they're passed into a component from a parent. So properties cannot be changed. When the octocat retrieves that property, it's read-only, it's immutable. It can't be changed. In this example, we have a card. Sorry, it's hard to read, so the theme got changed. We have a card component, right? And it's going to be used by a deck. It's going to have this prop's face and this prop suit, kind of like our card class from Blackjack. And in our deck class, we're just going to say this card's face is a 7 and this card's suit is a hearts. If this class wanted to change face and suit, it cannot. Right? It's received these things from its parent as properties, and they cannot be changed. They come into us from our parents. If you wanted to change something, we need to talk about state. So if properties are unchangeable, what do you think is true about state? They're changeable. So state is used to store information that's local to the component and is able to update and re-render the component. Right? So state stores information. Props kind of do the same thing, right? They store the name of the cat or the image. State can do the same thing, and it's local to the component. Every component has its own state, just like every component has its own properties that were passed into it. The difference though is we can change the state. And React is super smart. When it sees the state change, it will re-render itself. So it's waiting, it's sitting around waiting for state to change, right? You
Is
create
that-
your component, you
Is
put it on
that
the
through
page.
something like always listening or?
It's part of the React code base that says, hey, when you change state, here's all the things I'm gonna do. So one of the things that it does is it re-renders itself, right, and changes what the representation of that object is. But it's also used to pass information into child components. So a common thing is for me to take my state and take part of my state and use that to pass to my children as their properties. So what would an example be? Like if we use that deck example, right? Maybe the deck has an array of cards, right? And it builds up a card from the top card on the deck, right? Well, if that top card on the deck changes, the properties of that child card change too, right? If it was a 7 of hearts, right? And now the deck changes, so the top card is the ace of diamonds. That card is going to retrieve new properties as ace of diamonds, and it's going to change.
Isn't the property of the deck changed too though?
No, the state of the deck is changing. So we use state when we want to change our own data, the data that we own, right? It's ours. It didn't come from my parent. I created it myself. So state is data that I create. I either create or fetch or import from a JSON file or get from somewhere. Properties are handed to me, right? I can do nothing with them. I just get them. State, I can say, hey, I need to go get some information from somewhere that I know I need, and I'll store it myself. And then I may pick that state apart and create child elements using that state, passed to them as properties. Right? So properties always flow down to children. They may come from hard-coded values, but these could also come from this deck state. Okay? And state is something that component can change itself. Right? So the thing to remember, people are going to confuse props and state for a long time, right? It's probably the number one thing in React that people have a challenge with. It's not the only thing, but it's the number one thing. Just remember, state is stuff I own. I created the state. I manage the state. It's mine and no one else's. And I'm going to take part of that state and I'm going to use it to generate my children. When I generate my children, some of their properties will come from my state. And I can change my state. And if I change my state, I'm changing my children's properties. We're going to see that in a second. Right? We use the pass data as our child components. It's sent from the parent to become props in the children. So this is what state would look like. So you'll notice a new function called a constructor. Right, remember constructor when we were building our cats and we were giving them names? Well, here it is again. But look what the constructor takes as its first argument. My props. So these are the same properties. This is the same as this dot props. So my constructor takes properties. And the very first thing I do, and you're going to write this all the time, is you're going to say super props. Right? Super is the constructor of my class's parent. So all we're saying is, hey, React, I was given some props. Here's a copy for you. So you're almost always going to see constructor props, super props. That pattern is a boilerplate. What it's saying is props were given to me when I was created. I'm just going to hand them off to React so React can do something with them. And I can also choose to use them, but React now has their copy. I've got my copy. And then the very first thing I do is I say this.state, my age is 36. Then when I render, I can say this.state.age years old. Right? So if this person component was created with angle bracket person age equals 42, that would be this.props.age. Those are the props I received. Here, the person is saying, I am 36. I don't need anybody to tell me how old I am. I know I'm 36. I created this data. If I create the data, it's my state.
Where'd you get the data from?
We just made it up. Right? It's right here. This person is saying my own age is 36. It doesn't come in from properties. I'm saying I am 36. I'm not waiting for somebody else to tell me how old I am, what this age is. It's not coming in as properties. It's coming in as creating an estate.
I just wanted to make sure I'm understanding, like in our Octodex there, we pulled all the cats from props. If I wanted to change just one cat without changing the props, I could do it in a state.
So the state always comes from the parent. So we're going to see in a second how that is, so hold on, and I think you'll
The
see.
state comes from the parent, or the props come from
The state is in the parent and goes to the children.
Okay.
So he was saying, like, I want to change cat. The change happens in the parent and flows to the children,
Oh, okay.
right?
Okay.
So you know how we're going through each of those cats, right? And we're creating the octocat. We're gonna see in a second how that works, right? Just hold on to that state. Like I just want you to like, if it's a mantra and you like sing it on your way to lunch today, right? Components own their own state and can change it. Properties are read-only. Properties come from parents.
So states can be changed.
State can be changed. State can be changed, properties can't. I own my own state. I get my properties from my parent. Right?
But the state comes from the parent
Yes.
as well?
Right.
Okay.
Your eye color comes from your parents. You can't change it. Right? You can choose your own career. Your career is your state. You don't get your career from your parents. Your parents may suggest a career to you, like, hey, here's please run my family plumbing business. That's your properties. And you're like, hell no, I'm gonna become a computer programmer. That is your state. Because you can change it. Right? But your eye color, right, you inherit from your parents. You can't, you have a pair of contacts to change it, right? But you
So
can't
you
change
can
your
like
eye color.
substitute information with state.
Yes. My state I can change, right?
Is
So
an initial state though passed from the parents?
no.
So wait, so
Properties are passed from the parent to the child.
So state does not come from the parents then?
I make my own state.
Okay.
I choose my religion, I choose my career, right? I choose who I'm gonna marry, right? My parents can make suggestions as properties, but I make my own state. Now, could I use the properties here to make my state? Sure, right? If my parents say, hey, you're gonna be a plumber, and I say, well, my state, my career is gonna be a plumber. I'm just gonna take whatever my parents' properties came in and assign that to my state, but I don't have to. I can say, hey, parents' properties, you're gonna tell me to become a plumber, but I'm gonna set my career to be a computer programmer. Because I can change that. I generate my own state. Now, if I have kids, right, if I have child components, I can say, hey, you should be a computer programmer, because that's my state, right? And then that child can choose. Right? State and properties work very similarly. State you create for yourself in your own component and can change anytime you want. Properties come from your parent. Right? We're just going to sit in that for a minute. Right? So here's another example, right? It's the same constructor. I've got state and age. But when I go create a child component like an age display, I can pass age to that coming from this.state.age. Maybe we'll look at this again. Maybe this is easier to look here. I think the code examples are easier to read here. And then we're gonna do a demo. Alright. So here's this person. Right, they have a state, their age is 36. When they go create a child component, they can say that child's property is my state. I'm taking my state's age and passing it down to you as a property. So the age display is going to receive its age property from its parent state. This is flowing state down.
So the child
So you mean
becomes
to the child.
36.
Mm-hmm. This age displays, this .props.age is going to be equal to 36 because it got it from its parent's state age.
So it flows down here and like literally flows down the page. Like this dot state is above.
No, no. So it's not visually,
Not visually.
logically.
Just logically.
So when we did octocats, right? We said my number is this cat's number, right? It's the same as saying, hey, my age property, if I went to go look at the code for this age display component, somewhere it's going to say this.props.age. Like what? How old am I? When we're saying that age display gets its age from somewhere, where does it get it from? It gets it from this component's state, its age.
Yeah.
Because state is something that I can set myself, but I can also just pass it down to any children I want. You're going to see this in a second. We're going to do a clock demo, and we're going to do a weather. We're going to refactor the weather API, and you'll see.
I guess the reason I
That's
asked is just because it was like above it. It was
Yeah.
inside the constructor
No.
area.
Yeah, no, it has nothing to do with the visual.
Okay, cool.
So if state is changeable, how do we do it? Right. So let's take a look at another person example. I can create a new person here and set their last name state to tenant. And I can have a function that says update my last name. And in React we use the this.setState method. So this set state comes from React. What it's asking for is a new object that becomes the new state. So anything that we change in here changes the state. So after we call this function, if we ask what the state was, this.state.last name would be Smith, and this.state.maiden name would be tenant. So we can add new state elements here, and we can change existing ones. And what will happen is, React will wake up and say, hey, somebody called this.setState, and it will re-render this using the new value. And this is actually wrong. There's no $sign there. So let's take a look at an example. Let's make a really simple example. So we don't need octocats anymore. Let's go into week 4, day 2, and let's create a React app. Let's call it a counter. We're going to make a really simple app that just counts.
Why did you use take?
Take makes a directory and goes into that directory in one step.
Nice.
But it's only available if you're using Easy Shell. So we're going to make an app to be the simplest thing in the world, which is going to count some numbers. But we're going to hopefully see some of the effects of how state and properties work. So let's add them. Let's add them dot here. Oops, it's a counter. Let's add them dot here, and let's close octocats, and let's yarn start. So let's if that start. One browser, cool. Here's our React app. Here we go. So here's our React app. Right, super simple React app. Let's change this a little bit. Here's our app.js. We're gonna get rid of the logo, and let's just have this have the number 1. Let's change the CSS a little bit. Go away. Font size 20 round. Really? Stop it.
What is that?
It's warning me about style lint.
Wow, it's really going through detail.
Line complete.
Tells you exactly what it is.
That's what it is. Yeah. Okay, cool. So here we are, we have this number displayed, right? But it's kind of hard coded in here. Let's make a new component for displaying the numbers. So let's make a component called number display. And what it's going to do is it's just going to, in its div, print out this dot props dot the number. That's all it's going to do. So here, instead of returning this div, we can return a number display component with the number being 42.
We have to import.
Oh, I have to import it. Thank you. Import number display from number display. So now I have a component that displays the number. There it is. Oh, and we lost our styling because it's no longer wrapped in a app class. So let's just say on the body, all of our text is huge. Cool. Right. So here's my app. Right. Now I can put multiple of these number displays. Right. I can put one number display and another number display, and have it's almost too big. Oops, and I don't want a semicolon.
Why did I put the semicolon in there if it was something outside of the
I
bracket?
don't know why it did that. I think when I was rearranging the code, I caught a spare semicolon. I think when I was moving this code around, I picked up a semicolon I didn't want. Alright, so here I'm passing properties. Let's just leave the 142 in here. And I'm passing properties down, and I'm using properties in the child. Right? This is just like octocats. I pass a name, an avatar, an image, etc. Right? So let's, in this component, let's instead use state. So let's say the state of this object is, let's call it my number equals 42. Oops, sorry, colon 42. So I've just set some state for myself. Inside of here, let's console.log this.state and see what my state looks like.
Why didn't I return two 42s?
Because I only rendering it one time.
But you called this state my 42.
Let's make this 12. Right, I'm not using that state yet. I'm just declaring it. So here's my state.
Got it.
So if I want to use the state here, right, and I want to pass my number down to their number, I say this.state.my number. Now I'm taking my 12 and passing it down, right? So let's do this. Let's talk about one of the lifecycle methods of React. So I want something to happen when this component appears on the page. There's a function called component didMount. So this function React will call as soon as this object appears on the page. As soon as this component gets thrown into the DOM, this function is going to get called. And I'm going to use a function we haven't used before called setTimeout. Set timeout. So set timeout is built into the browser. And the way set timeout works is it takes a function to call and an interval in milliseconds. Right, so this is like map or filter. It's a function that takes a function. And it's going to call my function once a second. So you see it's being called. Oh, sorry, I don't want to set timeout. I want to set interval. Set timeout only gets called once. Interval will be called multiple times. Called, 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 right? So now as long as this page is going, this little function is going to happen once a second.
Will that ever fill up your memory?
Nope. So let's do this. Let's let the current number equal to this.state.my number. Let's say current number plus plus. console.log current number.
Count.
13. Right, it's not counting yet because the state isn't changing. So if I want the state to change, I can say this dot set state, and inside of here I put the object that updates to the object I want to do. So what attribute of the state am I changing? My number. And what am I setting it to?
+1.
And where's that stored?
Current number.
Current number. Anybody see what's happening to the user interface?
Yeah.
It's changing. Did I tell the user interface to change anywhere?
Yeah, down where it says return my number.
Yeah, I didn't have to teach it anything. Right? As soon as the state changes, it re-renders this component. Right? As soon as this set state happened, React was like, oh hey, my state has changed. What do I need to do? I need to recreate this component. What is this component? It's a div with a number display. Well, where does number display get its number from?
My number.
My state. So every time this happens, this child is getting a new property. This number here is changing. If inside of here we said console.log, I am the child component, and my this.props.the number
Could they put that in?
is this.props.the number, we'll see that because state is changing here and this is being re-rendered, this state is updating, therefore it gets passed as the properties to the child, and the child's properties are changing. Let's go look at the console. I am the child component, and my this.props number is 33, 34, 35, right? That component is sitting there and is being told by its parent, your properties have changed, your properties have changed, your properties have changed. And when its properties are changed, it will re-render itself. It's like a tree of re-rendering. My state changed, and since I'm passing my state to my child as a property, its properties are changing, right? And this updates automatically. To the point that if we had this in here twice, right? I don't have to teach it how to repaint itself. I don't have to query some selectors and update things or add children or what. I say the way my app works now is it's going to maintain the state of its current number. And once a second, we're going to update that number. Because in my render, I passed my number from my state to my child as its properties, React is smart enough to say, cool, I will re-render that child and give it new properties. That child is smart enough to say, oh, hey, cool, my properties changed, I will repaint myself. The way it happens is like super more technical than that, but that's a good analogy to think of, right? I mean, we can even do things like, you know, let's change this to a UL. And then these LIs.
How often does it update itself?
Yeah, well, as soon as the state changes.
So if you set that countdown time to like 10 milliseconds,
Yeah.
is it going to like what overtakes? Yeah.
I mean, look how fast, right? Literally, like instantaneously, right? This is happening every 10 milliseconds, right? Now it's more like a second counter, right? App.css. Let's take all ULs and LIs and margin 0, padding 0, just for reasons, right? What if we had this number increment by 2? Right? Literally the second my state changes, I gotta redo myself. Right? I repaint myself. How I repaint myself is by passing my number down to the child. Let's have this back just to one number. So what if we had a second number display and we sent my number +1? Kind of picture in your head what you think is going to happen.
It's going to be one ahead.
I mean, two of them, and one of them's ahead. Right? So what's happening? What's happening in this component? Here's our console. Look at this. Two different child components. One is getting the number of 36, and the other one's getting 37, because this component's getting the number. This component's getting the number +1. Right? So what if we had two? Let's call this my increasing number. Let's call this my decreasing number. So let's do this. Let's make this set state a little simpler. Let's set my increasing number to this dot state dot my increasing number +1, and let's set my decreasing number to this dot state dot my decreasing number -1. Now down here, let's use my increasing number, and here let's use my decreasing number. Right? All I'm doing is maintaining some data in my state. I got one number that's increasing, I got one number that's decreasing. I'm going to use the same child component, but pass it different versions of my state, different portions of my state. Does this number display know anything about increasing or decreasing numbers? Absolutely not. All it knows is I'm going to get a property of a number, I'm going to put it on the screen. The parent is controlling how to use those children. Right? And all I do in my render here is say, what do I want on the screen? I want a number display where the number is my increasing number. I want another number display where the number is my decreasing number. We've declared how we want this to render, and then in other parts of the code, we just change our state, and magically, poof, the screen refreshes and redisplays. Right?
Can you add other things like like arrays or objects?
Absolutely. Absolutely.
So you put everything inside that one state, or do you do multiple?
I can make objects. It's an object, so I can put an object inside of an object inside of an object inside of an object.
But you wouldn't do like another this dot state.
Oh, yes.
No.
Yes.
Yeah, each component only has one state.
Okay.
So what if let's do this. Trying to think how to best show this. Let's. I don't know if the Octadex one is going to work. Let's do this. I'm gonna add this code. How much time do we have? Oh, we got time. Cool. Let's take somebody. Let's go here. Simple state-based React number counter. Somebody who hasn't already shared their code, so not Ben and not we used Gabe. Do we use your block, John?
Yes, we did.
Okay. So somebody else who has a weather app, they would like. I saw your hand first.
Did you stop the video mode?
I did not. It's still going. GitHub.com leafsicle
Yeah. SICLE.
Hey.
weather API. Here's what we're going to do. We're going to turn your weather API into a React app. So let's Reactify your weather API and see how we will use an API to update our state. So let's come back and let's create another React app. Create React app, weather API Reactified. So at the same time, we'll take your code from non-React to React. We'll see that, and then we will see how to connect it to the API. This is probably the number one thing we do in React is we connect these things to APIs, because the data's got to come from somewhere. It can't always just come from static data or from a counter that's going to increase. So let's go into weather API Reactified, and let's start Atom, and then let's yarn start. Yarn start. Yarn start. I yearn for starting. Yarn start. Yarn start. And the spelling's notorious. Okay, cool. So here is our, let's close the Octadex. Let's close the API. Let's close this.
So the notes are still in day 3 or day 4?
Week 4.
Week 4 or day 2?
Day 2. Cool. So here's our app. Let's see. We've got source. Let's go to the app. Let's get rid of the boilerplate. Let's go take a look at what we got inside of here. So we've got public main.js. Cool. So let's look at your. Actually, let's look at your HTML.
It does the thing.
That's the thing with the thing. So we've got a header and a main, and then some weather conditions. Perfect. Cool. So let's take this, and let's just have, oops. Let's just have this return. This. So we'll put this in a div so that we can have 2 things. Let's go steal your, what's going on here? It doesn't like your embedding, these aren't self-closing. There we go. So inputs are self-closing tags like images are.
How'd you just do that for all of them?
What's that?
How'd you
It
do
didn't. It just reformatted it. That was prettying my code.
That? Oh, you saved it?
I did save it. So let's go grab your CSS. And let's go into index.css. Let's go into index.css, please. And let's paste. Cool. There's our CSS. What does our app look like? Weather API. And what else did you have in here? You had an image, right?
Yeah, there's a background and then an icon on the page.
Background.
Wow, that's cool.
That's
Not quite as cool as mine. Lincoln.
That's a lot of animation.
let's download that background image. Cool. And then how did you use it?
Here's some use.
An image here. Okay, so there's an image up here. So let's use our import tool.
That's self-closing.
Let's import lightning from. Oh, you almost had a lightning image. Oh, the background is your back. I get it. Your background is your background. Let's not do the lightning one yet. Let's just see if we get the background. No. Oh. There we go. Cool. Maybe we'll just stop there for styling. Okay. So down here we have your UL of weather conditions. You're gonna render that. Let's extract that into a weather conditions component. Right. So we need to go make a weather components. Let's make a new file, weather components. .js. Let's declare our class weather components. Save this. Wait, not components, weather conditions. Undo this, delete. Weather conditions. I got components in the brain. Weather conditions.js. See here. Weather conditions. And then here, in our app, we will import weather conditions from weather conditions. Cool. Let's move your UL into weather conditions and have that be what it returns. Alright, so we're just moving that code, kind of like what you did in your refiltering Octodex. Right? But what we would like to now do is have something happen when we type in this value and press enter. Right? We want something to happen. Let's first add a constructor that takes props. We'll call super props.
So we're pretty much always going to add props.
If you're going to make a constructor like that, yes. So let's take a look at your code where you get the weather. Actually, let's first take a look at the code you have when you render the weather. So in your conditions, this is what you're doing. In your weather conditions, here's your code. So inside of your UL, you're making a couple of LIs. So let's format this so it looks nice. Really? We just took out my empty li, ul, save. Okay, so you have an li, your first li is for the temperature. And we can say it is currently this.props.temp. So I'm just looking at what you manually created, and I'm just going to assume that there's a property called temperature that's going to be passed to me. Right, it is currently this.props.temp. Let's come back over here, and it says it is currently nothing. Right, if I pass the weather conditions as temp equals 75, it is currently 75. What's next that you have? What's your next li? Your next li says with a humidity of this.props.humidity. So your next li is today's high is this.props.day high, and today's low is this.props.day low. And that kind of reproduces all of this. Right. So now I know that I have to pass at a temp, a humidity, a day high, and a day low. Temp, humidity, 100%. Day high is 100, and the day low is 50. It's going to be a wild day. Right? It's crazy. It's crazy weather out there. Right. So there's our default weather. Right? Maybe what we say is unknown, right? We don't know what the weather is yet. We're gonna go find it out. So let's just default it to this. Let's go take a look at your JavaScript code where you actually get the weather. So that's a fetch. So here's your fetch. Let's actually, before we do that, let's set a state. Let's do it this way. Let's make our state be object that has a temp that is unknown, and a humidity that is unknown, and a day high that is unknown, and a day low that is unknown. And then instead of all of these here, we just replace these with our state. This dot state dot temp, and this dot state dot humidity, and this dot state dot day high, and this dot state dot day low. Right. So we started with hard-coded values. Now we're just passing down what those things are from my state, and everything still works the same. I initialize my state here, and then I use the state here. Those values flow down as properties to my child. Now I'm ready to start using my API. So I say, hey, once the component did mount, I want you to do some code. When this component appears on the HTML, right? I'm gonna go do something. What I want to do, I want to go fetch that. I want to go fetch that weather from the API. So here's your fetch code. So for now, let's add another state that is our search. Let's just make it Tampa. So that's the other thing we're going to do. So here, this is this dot state dot search.
Do you need that $sign?
I do, because this is a literal JavaScript string.
So it's one.
And I don't actually need that because I can just add it like this. If the only thing that's going to be inside of your interpolated string is another string, you don't need to interpolate that string. You just add it. So now, rather than this, all I'm going to do is call this dot set state and pass it a new object. What am I going to do? I'm going to set the humidity to the JSON humidity. I'm going to set the temp to the JSON temp. I'm going to set the day high to the temp max and the day low to the temp max. So now as soon as the component mounts, I'm going to do this fetch. When the fetch is done, I'm going to ask the object to change your state to set the humidity, the temp, the day high, and the day low. This down here, this entire thing will refresh. Let's do this. Let's say for this dot state dot search. Oh, yes, I have a $sign. It's going to be for money Tampa. I don't need the $sign there. Oh, and I don't need these semicolons here. I need commas because it's a JSON. Right, we're not assigning variables. We're making a JSON object. So did you see that it said unknown for a second?
Huh.
Where did it pull the unknown from?
The unknown is what we set the state to initially. Let's make the web page really slow. So let's go into network and let's pretend, where is that thing? And let's pretend that we're on a super slow 3G network. So here comes the page, right? The state is unknown, it's making the request, and then it updates. So the first time we saw the page, all that was coming from up here, right? So, oh my god, this is from the state. Right? So when we load this, we're going to get, it is currently, oh my god, this is from the state. And then you'll be able to see the fetch happen, hopefully. So slow. Okay. Now you're going to see the fetch happen. There it goes. Right, we're waiting for it to come back. Oh, it did come back. Let's reload this again. If you watch down here, you'll see the request come for the weather API. There it is. Boom, came back. So what's happening is the very first time this whole thing renders, our state is, oh my god, this is from the state, unknown, 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 unknown. As soon as this component mounts, we're going to fire off the fetch. When that fetch comes back, all we do is we change the state, right? And we set the humidity, the temp, the day high, and the day low.
So now since the page is loaded, if you type something else into the input and hit search, then it's
Nothing happens
you
yet.
can't.
I haven't looked anything up yet.
Ah, right.
Let's do something. Let's make it so that when I click on search, we search for the weather in Orlando instead of in Tampa. So there's got to be a way that we can wait for a button click, right? This is our old query selector, query event listener, etc. It's easy. It's easier now.
Nice. I didn't really like the query selector.
So on our button, we're going to say on click.
Nice.
When we click this button, we're going to call this dot handle search. Handle search is a method we're about to define. Handle search is a function that takes an event and does a thing. Boy, doesn't that seem familiar?
Function.
This is like our query event listener functions. You'll notice that I'm defining them with an arrow syntax, because I want you to define all these with an arrow syntax, because it'll avoid a complication we don't want.
But you don't have to say let or const.
Hmm?
You don't have to say
No.
let or const.
No, because these are behaviors of the class. This is a method of the class, which is why down here I say this dot handle search. This component's handle search, which is defined here. So now what I want to say is I want to say this dot set state. What am I changing?
Search.
Search to Orlando. And what I really like to be able to do is call this code again. Right? Actually, let's do this. Let's say let search equals to Orlando.
What if you wanted a text box though?
Well, that's on the DOM side. Now we're working just on the JavaScript side. So if I change the search to Orlando, I'd like to rerun this code. I'm going to turn off this slow PG. Right? Because this has got all the fetch stuff in it, right? Let's make another method that says fetch the weather. It's going to be a function that takes the search and it's just going to do the fetch part. So we're going to move this code down here so we can reuse it. So when our component did mount, let's call this fetch the weather and pass it as the search, this dot state dot search. Alright, we're saying we're going to need to fetch the weather in two different places when the component mounts and when we click the button. So I make a function for it so I don't have to duplicate that code. And then in component did mount, I just say, hey, component mount, fetch the weather for what city, whatever is in my this dot state dot search.
And it's handle search because you called the button down there.
And because I called the method on click handle search.
Right.
Taco Tuesday. I could call it anything I want. Usually it's handle search, handle click, do the thing, some kind of method like that. So let's change the state and let's call this dot fetch the weather for Orlando. Let's see what happens. Let's reload this. And click. Did the weather change? Nope. Oh, because up here we're searching for search. Search Orlando. Weather changed.
Huh.
Right? So anytime I call fetch the weather and I tell it what to search for, it's going to do the fetch, get the response, set the state. Actually, what we can do is we can move this up here. This is even better. Let's set the search to whatever we were past of search. No, we don't even need to do this. So now the name and the temperature will change at the same time. Search. Did I click it? Click. There it goes. It needs to click harder. Click. to get this value here, right? So that means we have to be able to get this inputs value. For now, what we can do is we can still use our old friend let search input equal document query selector. What did you call it? Search? And let's pass it search input dot value. Now we're not hard coding Tornado anymore. Now we can type in. Okay. Shoot, this is gonna be for another day. I'm gonna punt. I'm gonna punt on this because I need to teach you something else before we can do that. So I'm gonna punt on that. For now, we're just hard coding the search for Orlando. Tomorrow we're gonna talk about inputs and some of those things because I don't want to blow your minds any more than we have to for one day. So tomorrow we're gonna figure out why can't Gavin type in this input. And I'm typing in this input but nothing's happening. We'll talk about that tomorrow. So the point for today is what we end up doing is we end up rendering our page with the state that we want to represent. So here we said, hey, weather conditions, your component's gonna take a temperature, humidity, a day high and a day low, and render yourself some way. We're gonna pull that information from my state temp, my state humidity, my state day high, and my state day low. We initialized it with a whole bunch of values, right? In the beginning, they're all unknown. That's why we get unknown and then the weather. You can see really quickly unknown and then the weather. So the first time this page renders, we have to give it some initial state, so something renders. Then as soon as the component mounts, we ask to fetch the weather. That goes out to the fetch API with whatever our search term is, in this case, Tampa. When it comes back, rather than having to call a function and delete DOM, all we're doing is, hey app, you have a new state. Your humidity is now this, your temperature is now this, your day high and low is this, and by the way, this is what we're searching for. This component, my own component, wherever my state changes, that's the component that's going to re-render. It's going to regenerate all of this and replace it on the page, including sending down that new state to the weather condition. Right? The weather condition is like, hey, I got a new this.props.temp, I got a new this.props.humidity, I got a new all of these things. I'm going to re-render myself. That's what causes all of this to change. Right? We get the new for Tampa because this part changes because of the state. We get new 86.11 because we're passing that temperature from my state to my weather conditions props. It's pulling that as this.props.temp. Right? We can even say here in this.props.search, let's call it city. Right? There's no city there yet because why?
You didn't do
Didn't
the word
define
state.
it.
Yeah. City is this.state.search. It's currently 86.11 in Tampa. Right? So just remember that state is my own stuff. I can change it. I can initialize it in my constructor. Right? I can give it a whole bunch of values. Then when the component mounts, I can reach out with the fetch API and get data. I parse it like we did before, but rather than have to regenerate anything, I just re-update my state, and the magic of React happens and everything repaints.
If you change the value to where it says the input, if you change that to search,
Change what to where?
so that right where it says value,
Mm-hmm.
if you change that, would it Chicago?
Won't do anything.
It'll change what pocket it's on my phone.
Because
Not
you
here.
declared it up there.
Yeah. What I want to do here is I want to say this is this.state.search. I want to change it up here.
Mm.
So down there, when you changed it in value, it changed
Nice
it
day.
to Chicago, but it didn't do anything to the temperature until you changed it like that.
Mhm.
No.
Yep. It's getting real close.
Yeah.
It's getting real close.
So, where's the real world application of the whole state thing? Because you could do this all on props, right?
Yes. So what if I challenged you to redo your tic-tac-toe game in React? What do you think the state would be? What components do you think you would have?
The board is.
You have a board,
And the
right?
X is
And what do you think and then your board would be composed of what components?
X and X.
Table data.
Cells, spaces, board positions, right? Not necessarily buttons, we're thinking components. So how would you describe each of those parts of a tic-tac-toe game? You wouldn't call them, if you were drawing them on a piece of paper, you wouldn't call them buttons or divs. You would say call them squares, right? Tic-tac-toe is a game of 9 squares. So maybe your board is just a div with square, 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 square. What do you think the state of your board is?
Blank.
Yeah, what's in square 1, what's in square 2, what's in square 3, what's in square 4. So when someone clicks on a square, all you need to do to repaint your entire board is change what's in square 1 to an X, change what's in square 6 to an O, change what's in square 9 to an X, and your board will repaint, and so will your squares. So what we're going to figure out often is that most things, when we look at them, is some level of state that we pick apart and we render in different ways. Right? I gave the example yesterday that Facebook, hopefully there's nothing weird on my Facebook today, Facebook is just a React application. So if we come in and we look at this in the React app, somewhere in here, hey, here's a messenger state provider with all this stuff in here, and here's states. These are probably all of the messages that are in my view. If I get a new message, all Facebook has to do is update this state, and this entire conversation view will repaint. So as soon as someone sends me a message on Facebook, all that's happening is in my browser, it's adding one more element to this array, and the page repaints.
Why did they have to separate the Facebook from the Messenger?
They didn't. In the web interface, they're not. On the mobile, it is.
Why'd they have to do that?
Because they like money. They made some decisions to separate it. You'd have to ask
They sold it?
Zuckerberg. It's probably easier for them to update as 2 different apps, Facebook versus Messenger. They wanted people to have Messenger without having Facebook. I don't know why they did on mobile, made them two different apps. I'm assuming if it's Facebook, it's for some monetary reason. It made them more money to have it separate. That's my only guess.
Maybe?
Or differentiate where the money's coming from.
Yeah. I mean, on the desktop, they're in the same app, but on mobile, they're on separate apps. Right? So the question is like, why can you do everything with props? You can, but at some point, the data in your system is going to change, and that's going to be your state. So what we see sometimes is an app component that has all the state, and all it's doing is passing props all the way down, right? And there's just one state, like your board, right? So your board has its state, and the squares have their props, and maybe those squares have other components and their props, and it's props, props, props all the way down. But as soon as the state changes, all those props reflow. So what you tend to see is state gathered in one spot, and props flowing down from there. I'm going to pass my state to children as a prop. They're going to pass part of that to another child as a prop. They're going to pull something out of that and pass it to another thing as a prop. But state tends to kind of congregate in one spot. And we can't do everything with props because then nothing would ever be able to change. Right? The only thing in a React application that can change is state. So I couldn't do this with the weather and change my this.props search. Right? And the weather can conditions component can't change anything, right? All it can do is display stuff that it received. Right? So it's just getting its props from somewhere else. Now, if it had state and was changing something, it could control its children that way. So the thing to remember is state is my own data, and I can change it. I initialize it in my constructor, and I change it somewhere else, like component did mount or on a click. And when that state changes, I repaint myself. And I can take some of my state and pass it to my children as props. Right? I can pull something out of an object and pass it. I can pass a number. I can pass a number plus 1. Right? I can control that state. I can pull things out, modify them before I send them as properties. The child that receives is like, hey, cool, I got a new this.props.temp. I'm gonna display whatever you gave me. Right? And then it doesn't really even matter if for some reason, right, if you wanted 2 of these weather conditions on the page. Right? Maybe your app has like the big weather conditions in the middle and small weather conditions on the sidebar. They're still just 2 different weather condition objects. Right? What if I wrap this in one div whose class name is huge? Right?
Did you change the city too?
We could. Right? And in my app.css, I declare huge is font size 3 round. Right? It busts out of the image or whatever. Right? The idea is like this could be over in a little sidebar, and this could be on the main page, and it could be styled different with CSS. It's the same component, just repeated twice on the page. And I don't have to worry about how it gets its data and how it updates. Right? As soon as I do this, they both change.
If you wanted to keep one static, and you, like, so if I wanted it to always display Tampa's weather on top, because we live in Tampa, then I wanted to be able to search other weather and it changed the bottom one, so I compare it to where I live, for example. How would you do that? Because right now when we click search, it changes both of them. How would you differentiate which one changes?
Let's make this. So let's make a nested object. So this is the search weather. Let's make another object inside of here that is Tampa weather. Cool. So here's what we're gonna have to do. We're gonna have to fetch the weather for this .state.search weather, and let's call this city. I'm tired of calling it search. Let's call this city. Let's call this city. And let's call this city. And let's call this city. And let's call this city. Let's call this city. And what else are we calling the search? City. So I'm just refactoring this to like say city everywhere instead of saying search. So it's more appropriate now. City and save. Now let's make this the search weather. Let's make this the search weather, and this the search weather, and this the search weather, and this the search weather. And then this is the Tampa weather. This is the Tampa weather, and the Tampa weather, and the Tampa weather, the Tampa weather, and the Tampa weather. Okay, so now we have 2. One says Chicago, one says Tampa. Now what we have to do is do this fetch twice. But now what we need to do is this set state has to be set state like search weather : it's not search weather, it's search weather for searching for Tampa, and Tampa weather for searching for Tampa. So I can do this a couple of ways. How do I want to do this? I'm gonna break your brains in one of two ways.
Mine's already broken.
So let's do this. Let's pass in search weather to this one, and let's pass in Tampa weather to this one. So now I'm going to say which state, which part of state, which part. Let's call it which part, right? So now we got to put parentheses around these things. So now which part tells me which state I'm going to change. So now what I have to do is I have to say something like let new state equal to an empty object. Then say new state, bless you,
Thank you.
bracket, which part equals an object that has these things in it. And then set state to new state. So what we don't know is in objects, if we have let person equal to name Gavin, color blue, number 42. We know we can do this, person.name. We can also make person, and we can give it the index and give it the name of the field inside that we want. So how do you ask for person dot, I need a thing dynamically, right? I can't put variable here, right? So if the variable is name, I want the attribute given by what's inside a variable. That's the part I want of person. I can't say person dot variable, right? Because that won't work. But if I say person index yourself, and the attribute I want is stored in variable, I get Gavin. If I make variable number, I get the number part of Gavin, right? So if I'm going to try and dynamically change this object in Atom, right? I'm passing, are you updating search weather or Tampa weather? But I say, hey, my object is going to be a blank object, and then set the search weather humidity, or set the Tampa weather humidity, and now you see I have two different weathers. Cool. That's the first way. Let me blow your mind another way. So what if I don't like this? And this is junk, and this is junk. Rather than finish the then here, I can just return the fetch. And I can then hang this off of here. And then here I can say this dot set state search weather is this. Let's fix this up. That finishes that. That finishes that. This finishes that, and then one here. And then this is, oh, we're not changing the setting. And then JSON arrow instead of here, this is Tampa weather. Console log JSON. What we get? still have this which part down here. Oh, and I do need this. This dot state dot search weather city. This will be this dot state dot Tampa weather city. Comma. There we go. So now the fetch weather, all it does is actually does the API, but it returns the promise, and then after we fetch the weather, we then, depending on if we're calling it for search weather or Tampa weather, I can call set state. And I could do different things if I needed to. I don't know which one I would use. I kind of like the first one better, maybe. This is a little more complex. But there are cases where you'll have something that fetches and just returns the JSON, and then you parse the JSON outside. But that's how you would do two different city weathers, right? And then you can imagine maybe I have an array of weathers, right, where each one has a different city, but I'm using the same fetch weather API, right? And then maybe that down here is a list of cities where I'm mapping over each of these, and I have different weather components, right?
Okay, because it's pulling everything.
Here's 6 different cities. They're going to make 6 different fetches and update 6 different components and render, right? So once you figure out that state is the data that's owned, and then I pass that down to my child components, as long as you're updating this object state correctly, right, all the things below it will change appropriately. So what we don't have anymore is searching for DOM and changing it and setting the text content or the inner HTML or creating elements. We're just literally declaring how we want the page to look, making that based off of state if we control the data, or props if we're past them. And as long as we maintain the state, we end up with the data looking the way we want it to look. Cool?
Very cool.
So homework